What's up, people? How are you? I'm doing okay today. I streamed on Sunday. I'm just gonna do an hour, and then I'm gonna go eat lunch. Then I'm gonna come back. I'm gonna do some more. So where did we leave off? We stopped at line 630. So let's jump over there, see what we were doing. Okay, so we were. Okay, I remember. Yeah, we were reviewing all of the list of objects, shared objects among non-adders to see if they're race condition prone. And since it's correct, card list. If click card active is set to false on client side with change from their check bool equal to true, then it is transferred from client side to server side, which means it is race condition prone. Gotcha. So we're reviewing clickable card list, but what is in question here is whether or not click card. No, we're actually reviewing clickable card list, but since clickable card list is cleared from here, whenever click card active is set to false, that means if click card active is set to false on the client side and change from dir check bool is set to true, then that means we are well, actually, if change from dir check bool is equal to false, means it's not changed from dir check. It's changed from outside of a data transfer. Then that's what we're gonna look up. Alright, so need to see when click card active is set to false. Okay, so click card active is set to false in event handler. So whenever click card active is set to false in event handler, that would go dang it. That would go here. And since the val is not going to be a tuple, because it's not being changed from dir check, the bool would be set to false. And then if val is equal to false, it's going to clear the clickable card list. So this actually is race condition prone. So clickable card list. Oh, I forgot to set my timer. we're already 5 minutes in, so we'll just set it to 57. Let's give a couple extra minutes. Okay. I was thinking I was going through, sifting through the thoughts here, and I'm wondering if clickable card list isn't actually modified. Well, if it isn't accessed on the main thread, which I'm like almost positive it is, all we have to do to check that is go to progression. Yeah, so it's accessed and modified. So yeah, it's definitely race condition prone. Just wanted to verify that. Trying to figure out where exactly we should. Man, I should have made a list in my notes of like race condition prone objects. I already knew that clickable card list was race condition prone, obviously, because I have a lock implement. So I already knew that. I'm just trying to figure out where I can write like where the proper place to write this would be. Okay, so here, alright. Clickable card list, verified race condition. Okay, so yeah, so I actually do already have this written. Let's see. So yeah, clickable card list and clicked cards list. Yeah, and we put verified race condition bonus, so that's already gonna have a lock implemented. So we're actually done with this already. We already like did this in the past, so that's cool. All right, now we're gonna look at verified race condition prone. Then we have deck instance. Okay. And we're specifically worried about the instance because we already looked at adders, attributes. I call them adders. Okay. Deck instance current. Right. So yeah, we're worried about whether or not deck is and this is gonna fall into the category of like if the attributes aren't race condition prone, then or race condition for an instance object like the deck, which has a lot of attributes, race conditions are handled at the attribute level, not at the object level. There's no reason, like, as long as that attribute is locked properly, the outer object is also going to be safe as well. So like describing the same thing to the same thing in a different way. So I don't think that the deck itself is going to be race condition prone. Like well, so we already verified that the deck, the discard pile, and the property discard is not race condition prone. So yeah, I mean that means that the actual object itself, the deck class instance object, is also not race condition prone. True. I don't see how they could be separated. Obviously, yeah. We don't access the deck itself, like, ever. Yeah, we're good. I just wanted to be diligent and make sure I check all this stuff. Alright, so now we're at game instances. Now this, we do have some class attributes here. Yeah, but those aren't even created and that one's not transferred. So like, we actually don't even have any class attributes. A lot of instance attributes. And obviously, like, if you're modifying the game, you're modifying one of its attributes. So as long as the attributes are safe, locked when they need to be, which they all are, we already did that, then like the object itself should be safe. Yeah, I don't see how they could not be. Same thing with locations. I mean, we're gonna be diligent here though. We're not just gonna assume. Let's actually look. Give it a good thought and not just breeze past it. So this one doesn't even have any transferred attributes, but it does have class attribute, right? Nope, not anymore. We changed that. So yeah, this one also, that's all it took. It's safe as well. Network instance, we don't transfer the network. Like, that's, I don't even have to look at that. Connections already locked. Wait a second. So the cons are already locked. I was just thinking about this stuff. Hmm. Conatter equals self s except. Okay, so we have the connection, then we have the address. And I think I'm looking at this right here and I'm like, well, technically, shouldn't I having trouble like visualizing this in my mind here. So I was thinking about how we have that bug, the intermittent bug that's probably related to some sort of race condition, waiting other player bug, where sometimes it just says that it's waiting for the other player to connect, even though it's connected. Um, this is a related section, so this is directly related to that, and I was just wondering us using con right here when we assign it right here, like so let's say this is connection number 2, so connection number 1's already connected. Now let's say connection number 1 is gonna send data to the other connection. Well, the other connection actually isn't connected yet, so you couldn't do that. Yeah, it actually doesn't. Yeah, it won't. This couldn't be a race condition prone line because this is prior to both connections even being initiated, right? Like, and this would only run once. Like, I mean, this wouldn't get run again, would it? Because we start a new thread, and then the threaded client enters into its own while loop. Yeah, well, because the cons are accessed by each separate thread, client thread. They're not accessed by the main thread. Um, but yeah, so this line would also be safe as well. Let me go up here and minimize all that. Okay, so we got our globals is equal to 1. And at this point, the other client hasn't connected yet, so con equals subcon 1. So this line should be safe from race condition because the other client isn't even connected yet to on the same thread. It could access this connection. It should be thread safe. Now let's say that we just keep going through here as if I'm client 1. Okay, so then we send to client associated client num, which would be 1. Okay, then we ask connection to ready to see then self-verified IE received is not equal to 2. 0 plus equal to 1 for each threaded client to verify is later deduced by 1 if client DC signature. The section is clients get stuck in one client ID. Okay, so now 0 and num is equal to 0. Int connect receive 1. Yeah, so these two, like whenever they get connected, they're only going to be dealing with their own data. Well, they do reference other con right here. So like technically whenever it's client 2 is connecting and they get to this section right here, this client num would be equal to 2. The other con assignment could be a race condition. But like it's not quite a race condition, because although the threaded client might be accessing the other connection, let's say at the same time the other connection is sending data or receiving data, that doesn't have any bearing on the connection itself. Like the connection itself is safe. Now, the issue with the connections is if we were to send data at the same time as another thread was sending data to that same client, the data would get intermingled. That's not good. So we're asking about whether that could happen, and ChatGPT or whoever let me know, yeah, that can happen. Like the data could get tangled up or whatever, so we do need the locks in general, I'm pretty sure. So con send, so then we send out the client num. Okay. This would happen for both 1 and 2. Send it out, and there's nothing wrong with that. And then we get a receive back. So then we receive the ID that gets sent back. And I wonder, is this line right here, is this race condition prone? Because we have if int con receive, so we're receiving, let's say this is client 2. So we're receiving from client 2, and so this starts at 0, research the verified is later reduced. So this is just a verified is later reduced by one of client DCs to ensure this section is run when they reconnect so the client doesn't get stuck in a wall. Client ID is equal to none. Okay. So they can't get past this point until the each client connection sends back its ID. So like I don't think this would be a race condition because it's only dealing with each client. Like we're not touching the other connection. So I want to say this is also safe. I don't see how this would not be safe. Because I was going to say, well, what if the other one's already entered into its while loop and stuff? But that's... I don't think that could... I don't think that could happen. Yeah, and I was worried about, well, what if the main thread's doing its thing and then it changes data and then that but we're not to the main while loop of the client thread yet, so there's no way like that could actually happen. So I'm pretty sure up to this point we're thread safe. And then we have if current client ID is equal to 1, the connection equals self con2. Now we enter into the main while loop. Once we enter into the main while loop, I just want to make sure, like, I'm pretty positive I don't need to add a lock onto this stuff up here. We got the connection send, that's and it's not gonna receive, like, there's no risk here for data to be corrupted. I'm pretty sure, man. I'm pretty sure this is safe. I don't think this has anything to do with the waiting other player bug. I think that's different. Anyway, so I'm just gonna move on. I'm happy enough with my assessment of that, and hopefully I made the right decision. But anyway, let's go back over here. I wanted to take extra time with that because we do have this bug associated with the earliest stage of the game. We have, what's this? Resets at the very beginning. Now we're in the main while loop. This is the receive section. Oh, so this actually isn't locked right here. Right? Am I right here? Like what? Wait, this is on client side. I'm tripping. I'm a dummy. Yeah, this is client side. We don't need lock on the client side. Doofus. Was I in client the whole time? Idiot. No, I wasn't. I was in server. Yeah, I was in server. I'm tripping. Yeah, because I was in threaded client. Yeah. Okay, cool. Just making sure I wasn't that dumb. So yeah, that all should be safe. Yeah, and it doesn't start the main while loop until threaded client has been verified for each one. So it's not going to enter into the main while loop until we get both of them verified. It's gonna enter into this. So until that second one gets verified, it's not even gonna move to the main while loop here. Yeah, so that's all safe. Okay, so now we're in the while loop, and I think this is when we have to worry about the locking. Now at this point we're sending data to both connections from each thread. So they're both accessing the same connection object to do that. Prior to the while loop, that doesn't happen. And that's the key right there, I think. Yeah, so I'm pretty sure all this is safe. And now we assign the con lock, and we should be using the con lock, which we are. Now right here, this ready, this should be locked. This should be locked, I think. Yeah. I mean, I'm pretty sure it should be. And then also right here, we're not using the con lock. So I'm slipping. Yeah, this needs a lock, dude. Right here. We should be using a so con lock would be assigned though, right? Yeah, so con lock gets assigned right here. So it's always going to be assigned. So then when we get to this point, con lock will have been assigned. Okay, cool. That's what I was making sure. Yeah, so this needs to be locked. This might be the reason for our, I'm glad I reviewed this. I thought I had all this taken care of, but apparently, not. Alright, so this one, we're gonna do the same thing. This needs to be locked. Yeah, dude, this might be it. I just figured out that race condition bug. But we should already have con lock assigned. Why do we have to assign? I'm confused here. Why do we have to? I'm hungry as fuck, dude. I'm hungry, like really hungry. I might stop and eat because I'm like starving. I wanted to do that hour, but fucking hungry. Like I can't even think straight. Let's just go a little bit more. We got 23 minutes. So we have with conlock, but conlock should already have been assigned. Like it gets assigned. And do we actually have to like run this again? Why do we not? Like, should this only happen once per threaded client thread? This assignment here of transfer lock, transfer list, all this stuff, like, it doesn't change. You know? Like, if our client ID, and this is in the while loop, right? Yeah. Now this needs to happen every time. This is filtering. But this right here, this assignment, current client ID is equal to 1. It sets the transfer lock, the transfer list. data storage dict, the send data storage dict, and the con lock. Like, what do we have con2 lock here? Hold up. Why do we have, if client ID is set to 1, why do we say con lock is equal to con2 lock? This is not backwards? It's weird. So this is for receive. Also, yeah, I'm pretty sure we can move this as well, but also, why do we have the con lock set to con2 lock instead of con1 lock? That doesn't make any sense to me. Starving, dude, I gotta gum. Fucking hungry, though. I went to the gym. I'm just like really fucking hungry. I didn't think I would be this hungry waiting this hour. Anyway, okay, so what is this con lock used for? I gotta highlight this now because I'm just like, what? I don't see myself making that mistake, but so this is the receive section. Yeah, this is for receive, I think. Yes, no. Transfer lock. Okay, so it's for other con. Okay, because we're sending data to the other client, the other connection. So that's actually correct, but there's some. See, yes. So this is not good. We need to change this to be called other con lock. Yeah, I need to modify this. I'm like, how did I not? Strange that I would even have it like this. Yeah, so first off, there's a few problems here I just found, but the main one is gonna be one of them right here. This con lock is actually other con lock. So yeah, this is actually other con lock. This is actually other con lock. What the hell was that? Did you see that little window pop up? Am I tripping? I like totally saw a little window pop up. I have a virus, I don't know. 17 more minutes, dudes. So yeah, this is supposed to be other con lock, and then right here we're we're supposed to say with other conlock. So now there's not confusion about what we're referring to here. Okay, so that part's fixed. Now the conlock is not actually set at this point. Okay. So then we use conlock here. So we're using the wrong locks here. No, because I just wasn't using a lock here. I just added these two. Okay, had some little issues there. See, now we assign the conlock. But this is the threaded client loop. So like we don't need to run this again and again. We don't need to check the ID more than once. Like the current client for this threaded client is always going to be the same. So like checking this again every time the while loop runs, it's just silly. It's never going to change. This is that client's thread loop. It's not going to change. Then we say conlock okay, so then we use the conlock, so that's good. Yeah, threaded client is never going to receive from the other client. So this would always refer to the current client. Right, okay, I'm getting it here. Just making sure this is all correct here. Okay, then we have the same thing. Yeah, this also doesn't need to be rerun. Like, we're always gonna send from the perspective of the threaded client ID, so 1 or 2. Because this is server side. Server doesn't receive from or send. Well, it sends to the other, but we would just use other conlock for that. So like this cal lock assignment could happen before the while loop, because we're always going to use that one for this thread. Conlock, same thing, other conlock. Okay, yeah, there we go. Cool, we did that. Yeah, so I see some fixes that I need to make. Some adjustments here. But I'm actually gonna go eat because I'm like starving to death. We're at 55 minutes, so we're 5 minutes. Let's go over here. Need to finish. Or did we finish all that? In server. Okay, yeah, that was it. Yep, cool. All right, so there we go. We did it. We made it to the time. All right, so I'm gonna take a break. I'm gonna go eat lunch real quick and come back. Might play a little bit of Overwatch or something in between, and just feeling kind of sleepy. Want to get like my energy going, you know, get my body going again. So yeah, I'll be back in, I don't know, hour, 2 hours, 3 hours max, and we're gonna do at least another hour so I can